hope everything went well on this little worksheet here. Got another video here for you. I'll go over the answers. I promise it'll be shorter than the last one here. So number one here, copper metal, Cu, of course, that's going to be solid, is heated in oxygen gas, so it's reacting with oxygen. Remember that oxygen is one of our diatomics, one of the Brinkelhoffs, so it is an O2, and that is gas, of course, and that is going to give us solid copper 2 oxide. Again, remember, Roman numeral 2 means copper with a +2 charge. The oxide is 2 blocks away from the noble gases, so it is a -2 charge. So copper 2 oxide is CuO, and that is solid. So when we go to balance this one, let's see, we've got 2 oxygens on the reactant side, only 1 oxygen on the product side. So the way to fix that, of course, is to put a 2 out in front, a coefficient. And that gives us 2 coppers on the product side. So to get 2 coppers on the reactant side, we put a 2 over there. Okay. Number 2 here, mixing sodium sulfate and barium nitrate solutions, right? So those are AQs. So sodium sulfate, Na2SO4, right? +1 for the sodium, and sulfate is a -2. And these are solutions, so that is an AQ. And barium is a +2. Nitrate, NO3, is a -1 charge. And so we need 2 of those guys, which means we need parentheses, right? So 2 outside the parentheses around around nitrate. That 2 is a solution, so that's an AQ. And then on the product side, we have a precipitate of barium sulfate. I had a couple of people ask me about precipitate. Precipitate, you may recall, is it's a solid that forms when you mix 2 solutions together. What happens basically is that these 2 compounds, these 2 solutions on the reactant side, essentially switch partners. And so we get 2 new combinations. We get the barium is now with the sulfate, so barium sulfate is BaSO4, and the sodium is now with the nitrate, NaNO3. And as I said earlier, the precipitate means that the barium sulfate is a solid, and the sodium nitrate is in solution, so it's an AQ. This is a very typical kind of reaction. We'll talk about types of reactions next week. But this is what's called a double replacement reaction. This is very common for 2 solutions to react and form a precipitate as a new substance that doesn't dissolve. It's very much what you did if you remember when you mixed a bunch of solutions together and you were looking for color changes and cloudiness, and some of them got goopy and gummy and stuff like that, all kinds of different colors, and you were supposed to name the new compounds that formed. That's what you were naming, were a bunch of precipitates. All right, so let's go to balancing here. Let's see, as it stands right now, we've got 2 sodiums over here, but only 1 sodium over here. So again, an easy way to fix that is to put the 2 out in front. That gives us 2 sodiums, but that also gives us 2 nitrogens and 6 oxygens. Or you can kind of think of the nitrate all together, since it stays together on both sides of the equation. So if I look over on the reactant side, I already had 2 nitrogens and 6 oxygens right here in that nitrate. If I want to add up the total oxygens on the reactant side and the product side, I've got 2 times 3, 6 oxygens right here, and I've got another 4 over here with the sulfate, so that's a total of 10. On the product side, I've got 4 right here in this sulfate, and then 2 times 3, 6 more oxygens in the sodium nitrate, and so I've got a total of 10 on both sides. Barium, 1 barium on each side, so that's good. So that is now balanced. Let's move on to number 3. Aluminum metal. Remember, metal with the one exception of mercury, which is a liquid at room temperature. If something says such and such metal, that is going to mean a solid unless it says otherwise. And a solution of sulfuric acid. Remember, anytime we have something that says acid, that means hydrogen with a +1 charge is the cation. Sulfuric acid is what we have here, so no hydro in the name means means we're looking for a polyatomic ion that has oxygen in it. Sulfuric, of course, tells us that we're looking for sulfur, and that ic ending means it is sulfate, right? I ate the acid and said ic. So sulfate, SO4, is a -2 charge. The hydrogen is a +1, so we need 2 of those hydrogens. So that's our formula for sulfuric acid. And remember, acids are always going to be solutions, even if it doesn't say solution, which it does this time, but even if it doesn't say solution, if it says acid, it's going to be a solution. So that's going to react together to form hydrogen gas, or to produce hydrogen gas. Hydrogen gas, hydrogen again is one of those Brinkelhoffs, right? One of the 7 diatomics. And so it's a 2, H2, and a solution of aluminum sulfate. Aluminum sulfate here is Al. The aluminum has a +3 charge, and the sulfate has a -2 charge. So we've got that 3-2 thing going on like we often have. So that means we need 2 aluminums to give us +6, and we need 3 sulfates to give us -6 to balance that out. And that is a solution, so that's an AQ. And now we have to balance this equation out. So let's see. There's kind of a lot going on here, right? Let's see what looks okay right now. Right now, the hydrogen looks okay, but the aluminum does not, right? We've got 2 aluminums over here and only 1 aluminum over here. Now, generally speaking, it's a good idea to leave elements that are alone like this, like the aluminum is, to leave that at the end. So we might try something else first. Sometimes it works out okay, but sometimes it doesn't. So let's look at what else might not be in balance here. Right now we've got 1 sulfate over here, 1 sulfur, 4 oxygens. Over here we've got 3 sulfates, 3 sulfurs, and 12 oxygens. So I can get 3 sulfates on the reactant side by putting a 3 right there in front of that H2SO4. So that gives me my 3 sulfurs and my 12 oxygens on both sides. But now I've got 6 hydrogens. So to get 6 hydrogens on the product side, I need a 3 right there. And I think the only thing left is that aluminum that we looked at the beginning. So I've got 2 aluminums over here, and I need 2 aluminums over here by putting a 2 right there. So that one should be all balanced right now as well. All right, let's look at the last one here. Mercury 2 nitrate. Again, remember that Roman numeral 2 means +2. The nitrate is a -1, so we need 2 of those guys to balance that out. And that is a solution, AQ. And that is mixed with potassium iodide solution. So potassium iodide is just Ki +1, -1. That's a solution. This is another one that's very similar to number 2, where these 2 ionic compounds that are in solution are going to switch partners. And so now it produces a solution of potassium nitrate, right? Now the potassium's now with the nitrate, and that's a solution, so that's an AQ. And we have, again, that word precipitate again, mercury 2 iodide precipitate. So mercury 2 Hg with a +2. Iodide has a -1 charge, right? It's a halogen, 1 block away from the noble gases. So we need 2 of those guys, and precipitate, remember, means solid is the state for that guy. All right, let's see what's not in balance here. We've got 2 iodides over here, but only 1 over here. We also have 2 nitrates over here, but only 1 nitrate over here. So it looks like we can fix that with just a couple of moves here. Put a 2 out in front here to give me my 2 iodines. That also gives me 2 potassiums, but if I want to get my 2 nitrates, I have to put a 2 out in front here anyway, which also gives me 2 potassiums. So now I've got 1 mercury on each side. I've got 2 nitrates on each side, 2 times 1 nitrate on each side. I've got 2 potassiums on each side, and I've got 2 iodines on each side as well. So this one is all balanced. And there we go. Those are the only ones you were responsible for today. For tomorrow, I want you to go ahead and finish up the last 4 on this page, and we will take a look at those on Monday. Stay safe, guys, and make sure that you're keeping up with everything, and I wish you and your families well.